Okay, given the region enclosed, we have y equals root x minus 2. That's the radical function on the left. Yeah. Find the area of the region below. So there's two ways that we can do this. We can either do top minus bottom, but if we want to do top minus bottom, what do you notice about the diagram? Yeah, it's two separate regions, right? So top minus bottom in this case means you don't have to change the equation, but it does mean you have to treat this like two separate regions. Uh, Meanwhile, the other option is doing right minus left. Right minus left, all we need is one integral. Because no matter where you shift your rectangles horizontally, the right endpoint is always sitting on the line and the left endpoint is sitting on the curve. There's no sudden switch in along the path of the region. But we do have to rewrite the equation as x equals. So just for practice purposes, on the quiz, you can decide how you want to do the problem. I'm not going to say, okay, this you got to do top minus bottom, or this you got to do right minus left. But just for practice purposes, let's do it top minus bottom first, and then try it right minus left, just to see if we can be comfortable with adjusting the bounds, adjusting the equation for right minus left. Okay, so do top minus bottom first. We do have to graph the equation to find the intersections or the intersection of the two graphs. Okay, go ahead and try that. The key's attached, but I will go through each problem with you. One of the surprising issues that students have with area is doing too much with the integral notation. I think maybe because we're so used to this method and washer method that we're squaring the radius, both for big R and little r, that I see some students squaring when they do the area formula. So when you do area, it's just top minus bottom or right minus left. We're not squaring the entire expression. Okay, so just keep that in mind that sometimes we overcomplicate things uh, and get the area formula wrong. Okay, so the intersection between the two graphs is x value is 3.697 and 1.303. That 1.303 is not needed for top minus bottom, but that it will come in handy when we do right minus left. So we have two separate integrals that we want to create. Okay, so for the left region here, top minus bottom, top is sitting on the root x minus 2. The bottom is sitting on the 0. We're going from 2 to 3.697. And that will be the area of that left region. Just insert that in the calculator. Plus, next one, 5 minus x minus 0, top minus bottom, from 3.697 to 5. That will give us the region on the right side under the linear graph. Add those together, we should end up with 2.323. If we want to do this right minus left, well, I want you to do it using both methods for now, just so that we can kind of get comfortable with all the integral needs for right minus left. We have to rewrite the equation, right? This 5 minus x is not a good form for, thank you, is not a good form for right minus left. We've solved for x, so x equals 5 minus y. And then if I solve for x here, square both sides, I get x equals y squared plus 2. Right minus left, 5 minus y minus parentheses, y squared plus 2. Make sure you put the parentheses here. And then we're going to go from the lowest to the highest y value. The lowest y value of the shaded region is 0. The highest y value we found when we did the intersection order pair, 1.303. Insert that in the calculator. We should get the same answer, 2.323. Any questions with? Okay. The work that we did for right minus left is going to come in handy for parts B and C, because parts B and C are all horizontally oriented. So we can reuse a lot of information that we gathered here. So look at part B. rotating around the line x equals 1, that's going to be a vertical axis of revolution. That's going to force us to draw our radius horizontally. And there's obviously a gap. We have to draw two radius, one that extends from the axis to the furthest boundary, and then one from the axis to the closer of the two boundaries. The equations we already rewrote using the right minus left from part A. So we can use those equations. We can use the bounds that we gathered as well. So right minus left, we have 5 minus y minus minus a 1. And then right minus left, y squared plus 2 minus 1. Big radius squared minus little radius squared. Insert this in the calculator, but leave pi out of the calculator. Attach pi at the end of your numeric answer. Okay, part C is a cross-section problem. Part C, perpendicular to the y-axis. Let's think about what orientation that is. Y-axis is vertical, perpendicular is going to make it horizontal. So we're going to draw a horizontal base length. So build your base, then adapt the area that we want to build on top of the base, and then extend it to the third dimension by including the integral notation. We can reuse the information from parts A and B. Okay, moving on, next page, page 2. A and B are rotation based. So, we have to decide whether to use disk or washer methods. So see if you can decide by looking at the axis of revolution in relation to your shaded region. Look at how they're interacting to decide whether we're going to be using disk method or washer method. So look at how the dotted line is. Where that dotted line is, it's right up against the flat surface of the shaded region. There's no gap. All we need is one radius. This is going to be just method for 2A. Okay, try part B. Mhm.
For A, when we're trying to solve for the intercept.
Yeah.
Why don't we just set out, why don't we set as ln4 minus x is equal to 1?
Yeah, you can do that.
So if I did that, then we'd get x is 4, right? Because you're trying to get 1. Wait,
I think it still ends up being a decimal, so I think it's easier to just graph it and look for the intersection.
the quiz, will all the integrals be able to be solved by calculator, or will we have to like hand solve?
You can do everything by calculator. However, part of the quiz review has problems that are non-calculator portions. So I do want us to practice with that with the U substitution. But on the test, you can plug it on the calculator. On the quiz, you can plug the calculator. Okay, part C. Part C is cross section, but it's a rectangle. So I'll talk about rectangles. Rectangles, we know it's base times height. So base, we build it based off of the description that they tell us, perpendicular to the x-axis. So it's a vertical base, top minus bottom. Now, the heights, if it's a rectangle, they always have to describe what the height information is. So here they say that the height is twice the base. So my base is natural log 4 minus x minus 1. My height will be twice that. So now rectangle is just base times height. So base times height, I just have to take the pieces that I have and put it together, and that will be my area. And then we put the interval notation around it. So with the rectangles, the height will always be described in a way where you can build it based off of the description. Again, no pi involved for most cross sections except for semicircles. So I see some students include pi for cross section because they see pi so much for disk and washer method that they forget it's usually not part of the process for cross sections. There's no rotation for cross sections. All right, page 3. page 3, you're going to find area of region S for part A, and then for part B, you'll do area of region R. I think both you can rely on just top minus bottom. No need to do right minus left for either. Any questions with page 2? Go ahead and start page 3, see how we do there. Okay, part C will be washer method, and part D, cross section Okay, if you're done with page 3, go to page 4. We'll spend the next 5 minutes, see if we can see how much of page 4 we can get through. Part D, once we build our base, then we look at the shape that we want to build. It's isosceles right triangle with leg on the base, so that's 1/2 base squared. Once you get that area represented, then you put the integral and your bounds around it. Again, no pi for cross section, except center circle. Okay, page 4. To find the y-intercepts that we need for our bounds, you can just plug 0 into the original function to get the y value. You don't have to use this equation to find the y-intercept. Use the original equation. This will be easier. Just plug 0 in for x. Natural log of 4 around 1.61. So that's going to be our upper bound for our volume. Rotating around the vertical line, so we know it's going to be right minus left. There is no gap between the graph and between the shaded region and the dotted line, so always use one radius, but we do have to rewrite the equation in a proper form. So solve for x, we have to exponentiate from both sides in order for us to get x by itself. So x equals 4 minus e to the y. On paper, you're going to use y to write down, to set up your volume equation, but in your calculator, you're going to use variable x. Okay, your homework uh, is to finish off the AP practice problems in the back of your packet. This is page 51 to 54. I'll check that tomorrow. And then tomorrow we'll finish off the rest of these problems on page 4. But we also need to begin to look at some FRQ topics, rate in, rate out. We haven't talked about that yet. Obviously, this is not going to be on the upcoming quiz, but I do want to start AP FRQ review. And then Monday, we'll circle back to area volume, have another full day of review, and then quiz will be on Tuesday. All right, come pick your phones. I have one more help session. That'll be Monday morning. Monday morning is having.